Okay, so I use this formula, density equals mass over volume. This one right here is asking for the density. It says calculate density and tells you the mass, the volume. So I just plugged it in, mass over volume, and then I got 2.70. Also use incorrect sig figs. And this one has 3 sig figs because there's 3 on that one and 3 on that one. This one says what is the mass. So again, it's asking for mass, which I did. M equals D times V, which is density times volume. I just input that in right there. Density right there for 13. This and then I got 81.5634, and then I rounded it to 81.6. The reason why I did 3 significant figures is because that's the least number of significant right there, because there's zeros after decimal is significant. That's 3 is the least amount of sig figs, and that's why I did that. So then that's why there's 3. And then this is again asking the mass. Well, then I use the same formula, mass equals density times volume. I input those numbers, so that's 25.0, and then the volume right there, which equals 17.55, and I rounded that to 17.6 because that's 3 significant figures, because this one right here is 3 significant figures, and this one is also 3 significant figures because the 0 right here is insignificant, because this number's after the decimal is significant right there. And then this one says calculate the volume. So for that one, I just basically played around with the volume with the formula and switched it. So for that one, it's volume equals mass divided by density, which is just what I did. I just plugged in those numbers, which equals 51.1, or not 51, 5.1. And I did 2 significant figures there because 25 is just 2 significant figures, and that's the least amount of sig figs. Again, volume equals mass over density. Just plug those numbers in, divided it, which equals 36.9 liters. That's 3 significant figures. That's 3 significant figures too that was given, which is why I rounded to that. And then for the conversion, I did 75 over 1 equals 1 kilometer over 1,000. The 2 meters cancel out as I crossed out. I don't know if you can see, I crossed it out, and then that's 75 divided by 1,000 kilometers, which equals 0.075 kilometers. And I did basically the same for this one as well. I did 16 over 1, basically made it to decimal, equals 1 yard over 91.44. I made sure the 2 labels basically like are like lined up together so I can cross out the label, like the centimeter. And then it equals 16 over 91.44 yards, which is the long number right here. And then I rounded it to 0.17 yards, and I did that 2 significant numbers because technically 0 doesn't count, because 16 is the smallest significant amount of numbers. And this one I did 2 sig figures because 68, it's just 2. And this one is 4 because number or zeros in the middle are placeholders and they are still significant. And this one is 3 because the 0 doesn't count, and then this 0 is after decimal, but it also doesn't count as well because the numbers that only count is 5, 9, and 6. And these 3 ones don't count afterwards. It's just 1, 8, and 6, because if I were to later switch it to another unit or whatever, these are still the significant numbers. wouldn't change it that much. Basically, if we lost the zeros, but if we lost in these, it makes it more significant. Okay, now I'm just rambling. But basically, this one is 3 sig figs. Cross out the 3 zeros. And this is 6 significant. And the reason why is because you have the zeros right here in the middle. They do count. Because 1, 2, 3, 4, 5, 6. I don't know if you can tell. I marked it or I ticked it on the bottom. So these 6 count. The 0 at the end does not. Because if you just switch it to another number, that 0 and the end could honestly be dropped. Unless there was a decimal. It's after a decimal. And then this one, I crossed it out because it's to the left. So these 3 zeros don't count. These ones at the end do count, including the 0 at the end because it's after a decimal. So that's 5. And I know the answer right here says 13.88. I added it and everything accordingly, you know, with the decimal adding up and whatnot. So it's 13.8791. I rounded it to the significant other, and the reason why I rounded it to 4 significant others is because the least amount of decimal places is 0.08. So then that's why I did that. So it's 13.8791. Round that. 9 makes that 7 go up, so which is why it's 13.88. And then for this one, I made all of the scientific notations all the same, which is 10 to the power of 4. So this one's the same, 9.1 plus, and then I moved it over to get that scientific notation to 4, which is now it's 0.0488. And I did the same with this one too. I moved it over, so then the power went to 10 to the power of 4, which is why it's 0.760, and then add it all up equals 10.7088. And then I did the significant number. So this is 10 to the power of 4, and then this is the, what is it? This is like this 0, and then that's an 8, but then you don't look at that, you just look at this right here. So then 0 cannot make it 10.8, so then it just stays at 10.7. So that's why it's 10.7 to the power, to the 10.7 times 10 to the power of 4, and that's why it is. Okay. And the reason why it is because that's just like one number after the decimal. And you look at this one, 9 right here, that's one number after the decimal, which is why I did that. So yeah. Okay. So I did this 2, 9, 4, 6, 4 significant numbers because it's a whole number and it's all numbers. That's why. And then if I were to move it and make it to scientific notation, my note is if you go to the left, it becomes negative for the power, and if you go to the right, then it's positive. This one, what is it? I went over, so it's 2.95 times 10 to the 2. I don't know, it's to the left, so it's a little weird, but it all checks out because if I double check myself and I times it, it equals this, so it makes sense. This one is 3. This one, the decimal's right there. I moved it over to the right, and it's making it slightly bigger number, so 0.573 times 10 to the power of negative 2. And again, I checked all of these later with a calculator just to make sure that I am on the right track. This one is 6 numbers. I took the decimal at the end. Well, there's no decimal, but if there was, I moved it over. So it's 3.57, and I did it to 3 significant figures, which is why. And that's 10 to the power of negative 5. And then this one I did the same too. So basically these zeros in the front don't count, which is why 174 is the only the significant numbers, which is why it's 3. And then I did 1.74 times 10 to the 4th. I made it a bigger number, essentially, quote unquote. Decimals right there. This 0 doesn't count, but the 0 in the middle between the 9 and the 1 does count because it's a placeholder 0. So then that's why there's 3 sig figs. And I moved it over 1, and that's why it's negative 1. And then the decimal is between the 2 right here. I moved it twice over there. There's still 4 significant numbers because that 0 is in the middle. So then I rounded 1.07. The 2 doesn't make it change or anything, so that's why it's not 1.08. It still stays as a 2. And I moved it over 2 spaces, so that's why it's negative 2. 0.982 to the power of 10. I put 3 because honestly that 0 in the front doesn't count because it's the beginning, and then the 10 right here doesn't really count either, and I moved it over 1 space, and that's 1 space. But it's 10 to the power of 2 because my tutor told me that 10 to the power of 1 does not really exist, and if I plug it into the calculator then I would get this number, so then that's why it's correct. And this is 10.5 to the power of 5. That's still just 3 significant numbers because these ones really don't count. That 0 still counts because it's a placeholder, and it would just stay the same. Alright, calculate the following provided you're answering the correct number of sig figs. Alright, so I put sig figs, the significant numbers above each number. So 1.35, that's 3 significant numbers times that. And then it equals 3.33045. I round it to 3 significant others, which is 3.33. The reason why it's that is because if you take the 0 and you look, it's under, 4 doesn't follow the rule, so that's why it stays the same. This 3 stays the same, that's why it's 3.33. I took that, divided by that, got this long number, and then the smallest significant number is 2 because 42 is just 2 significant numbers, which is why I just rounded to 25. And then this one I added together. I lined up the decimals and everything, and the least number after the decimal is just 1, which is the 35.5 or 35.2 right there, and there's just 1 number after the decimal, which is why I drew that line down. It's 53.2. That 1 doesn't make the 2 change or go up, so that's why I squared it off and just put 53.2. And then for D, I subtracted, lined up the decimals and everything, and that number is 32.50, which I just dropped off that 0 because there's the smallest number of sig figs is 28.9, which is 3 significant numbers, which is why it's just 32.5, which is why it stayed the same, and it didn't become 6. It stays the same. All right, and then I multiplied it, got that number, and then the most significant amount of numbers is just 2 sig figs right there, which is why I just I rounded. That 2 does not make the 7 go up at all, so it's just 6.7 right there. Yeah, that's 7 right there, 6.7. Added that up, did the decimals, line them up and whatnot. Least amount of numbers after decimal is just 2, so which is why I chopped it right there. 3.35. 1 does not make that 5 go up or anything, so it's just 3.35. And this one, you see again that I put the sig fig, so this 150 is 3 sig figs, 4 is just 1 sig fig. The number is 37.5 but this 4 is just 1 sig fig, which is why I rounded it up to 38. And then I multiplied this first, and then I added it, which equals 0.15598. And the reason why it's 0.16, or why I rounded it to that, is because I looked at, what is it, the amount of sig figs right here, because these zeros right here, they don't technically count, so that's just 2 sig figs, which is 1 and 2 after the decimal, which is why I did that. So then I took that, I looked at the 5 and the rule where if there's still numbers after the 5, then you round it up, which is what I did, which is 0.16. And then I divided that, got this long number, and then I rounded to 4 sig figs, because right here, if you look, that's 4 sig figs. And then I added that, and then divided by that, which equals this long number, and then I rounded it to 760.01, which is 5 sig figs. And the reason why I did that is because this right here is the sig fig, so that's why, because there's, yeah, okay.